interval estimation. So now we're going to use the standard error of the mean to create a bracket or confidence interval to show where good estimates of the mean are. So I'm going to show you this two different ways, one with without assuming a normal distribution and one with assuming the normal distribution. So if we have at least 20 observations, people, whatever, the thing that we're using to estimate the mean, if we have at least 20, then the sampling distribution of the mean should be pretty good. So the sampling distribution will be unimodal and symmetric regardless of the shape of the underlying distribution. So you remember I showed you the dice. That was a rectangular flat distribution. We took the mean of two of those things, and it was a beautiful a beautiful distribution already with just two. So if you don't want to make any assumptions about normality, then you could go three standard errors of the mean to get a confidence interval. So the probability that the sample mean minus three standard errors is less than or equal to mu, is less than or equal to the sample mean plus three standard errors of the mean, is greater than or equal to 0.95. So what that says is we want to know where the population value of the mean is, and it's a good bet that it's around the sample mean, because that we know on average the sample mean is going to get us the right answer. So our best guess is the sample mean, and it's somewhere in that neighborhood. And we're going to go up and down three standard errors. So these are three standard deviations of the sampling distribution of the mean. It's not the raw data we want, it's the standard deviation of the distribution of the mean. So we go up and down three standard errors, and we should have the mean in there 95% of the time we do that. So for example, if the mean is 100, that's x bar, standard deviation is 14, and we have 49 people, then the standard error of the mean is 14 divided by 7, square root of 49 is 7, and that's 2. In our bracket, we would go up and down 3 of those. So 100 minus 6 is 94, and 100 plus 6 is 106. So our interval would be 94 to 106, and probability is 0.95 that our population value of the mean is in there somewhere, 94 to 106. P is the probability of sample. So in statistics, what you say is the probability of a sample, and not, so the shorthand way of people saying this is the probability is 0.95 that the mean is in this bracket. But statisticians bristle when you do that. They say, no, the mean is either in there or it's not. There's no probability. Either it's in there or it's not. The thing is, 95% of the times you do this, the mean will be in there. So it's the probability that your bracket will contain the mean. In any particular case, it's in there or it's not, and you don't know. But you defend yourself saying, well, look, 95% of the times I do this, it will be in there. If you want to talk about the probability of the mean being in there 95% of the time, then you have to go to Bayesian statistics, which is a different branch that we're not going to deal much with in here. Okay, so time to review. What is a confidence interval? Suppose the mean is 50, the standard deviation is 10, and n is 100. What's the confidence interval? Well, I bet you're going to get that because it's sitting right there on the slide. So that disappears during the slideshow, and then I show it later. But ask yourself, what's a confidence interval, and see if you can't work out with some other numbers what the confidence interval should be with a standard error of the mean. Standard error, yes, of the mean of 3. Okay, so a confidence interval is a bracket that's intended to contain the parameter a certain percentage of the time. And so with our example that we gave, standard deviation is 10, n is 100, square root of 100 is 10, so our standard error would be 1. The confidence interval would be 50 minus 3 times the standard error, or 50 minus 3 times 1, so that's 47. For upper, it would be 50 plus 3, or 53, and so our confidence interval would be 47 to 53. And so we'd say our 95% confidence interval is 47 to 53.